name is Emma Geiske, and welcome to my presentation about the planning of the newest Canoe Slalom course for the next Olympic Games. Canoe Slalom was an event originated in 1972 Olympic Games in Munich, Germany. The Canoe Slalom is a timed event where a canoe or kayak is used to navigate artificial white water. There is a total of 18 to 25 gates of the red and green variety. Green gates are entered downstream, and red gates, 6 of 8 gates, are traveled upstream. I have chosen this fluid application because of its ability to mimic a natural system and its significance to the world. As an overview of this course, the objective is simple: to create whitewater, which is a usually naturally occurring when shallow waters flow over rocks, embedding them with air to make the waters white. Since power is required to run the Canoe Slalom is quite high, my goal as an engineer is to make the system as efficient as possible as to not lose any energy. This also helps with affordability. Canoe Slalom courses utilize materials from well-managed sources and those that are in low energy and impact. Energies that are used try to be clean and auxiliary, which include hydro, solar, and wind varieties. The course must be able to be used for training and other competitions in the future, and must be held structurally. For the Olympic Games, the required whitewater strength is between grade 3 and grade 4. Grade 3 whitewater, it has medium characteristics but irregular waves, and grade 4 have waves large and turbulent but are predictable for our athletes. As for the materials used in Canoe Slalom, concrete is usually used as a structural boundary. We can use precast concrete, short concrete, or spray concrete. Usually there is also a damp-proof geotextile membrane and a suitable drainage solution. As for the water can be salty, treated, and or fresh water that is suitable, and water at a minimum must be at secondary contact quality. Water also must be a minimum depth of 1,000 millimeters in eddies and a nominal depth of 1,500 along the center line. The interior shape of the course is usually trapezoidal, and thus calculations that are made will take this shape into account. For example, the hydraulic radius is directly related to the shape of an open channel. Reynolds number is also calculated from hydraulic radius, and the Reynolds number determines the flow, which could either be laminar or turbulent, and will determine the level strength of the whitewater. The more turbulent the whitewater becomes, the stronger it will become. As mentioned previously, we are trying to use green and renewable energy, which could be expensive, and if that is the preferred power method, these calculations are crucial for the project's cost. Thus, the energy in Bernoulli's equation is crucial for calculating balances and losses throughout the course. The team must track where any minor losses may occur to reduce its effect on the energy required to run. The course will also need to utilize any potential energy given to the water from the various pumps to its full potential. Placing a turbine at the bottom of the course may help capture any remaining kinetic energy from the system. Lastly, drag, pressure, and external forces can be quite the problem for any system that includes flowing water. External forces can cause the system to wear over time or cause unwanted movements in its parts. For example, the red and green gates on the course need to be situated above the water to prevent any damage or breakage from the water or canoes. Since Canoe Slalom courses are not significantly deep, there may be little pressure caused forces to calculate, but they should still be considered when building the course. Thank you for listening to my presentation, and hopefully this helps us build a Canoe Slalom course in the future for the next Olympic Games.